Welcome to International Forum. The recent outbreak of the swine flu has highlighted, once again, the need for better understanding of the important questions of pandemics, pandemic preparedness, and a host of related questions, such as the availability of vaccines and drugs for treatment of infectious diseases and how we get and pay for them. Infectious diseases neither recognize nor respect national borders, and as such, the threats they pose are truly global in nature. No country is immune. Joining us to discuss all this today is Professor Adel Mahmoud, a distinguished medical scientist and global health policy expert with a joint appointment at the Department of Molecular Biology and the Woodrow Wilson School of Public and International Affairs at Princeton. Before coming to Princeton in 2007, Professor Mahmoud was president of Merck Vaccines for over 10 years. During that time, he oversaw the vaccine program that resulted in 4 new vaccines. Vaccines for the human papilloma virus that causes cervical cancer, vaccine for shingles, for rotavirus, which causes chickenpox, and a combination vaccine for measles, mumps, and rubella. Professor Mahmoud's prior academic career spanned more than 25 years at Case Western Reserve University and the University Hospitals of Cleveland, where he held leadership positions at both. Professor Mahmoud's extensive field and policy experiences with infectious diseases in the developing world have helped shape the current global strategy for controlling infectious diseases adopted by the WHO, World Health Organization. His work has also contributed to the current policy debate on such important questions as bioterrorism, microbial resistance, impact of globalization on infectious diseases, and containment strategies for pandemic flu. We're very, very happy that Professor Mahmoud is joining us today. Welcome.
Thank you.
I think I'd start by asking you about the swine flu. We've had a recent outbreak or scare. As of the first week of May 2009, the WHO has confirmed 2,099 cases in 23 countries with 44 deaths. Now, was that a pandemic? When does an outbreak become pandemic?
Well, an outbreak becomes a pandemic when it crosses the borders of multiple countries and crosses the borders of continents. So, in effect today, this H1N1 influenza virus is infecting individuals. So the transmission is human to human in approximately 30 countries. So that is the definition. Now, the World Health Organization has levels of defining the spread of pandemics, and the organization has characterized this spread to be at level 5, which is just short of being everywhere in the world.
Now, there has been increasing criticism of the WHO for overreacting, for unduly alarming the world about the risk, the threat posed by this swine flu. Do you agree with that?
No. And the reason is very simple. You can never trust what the influenza virus will do. This is a virus by the nature of its genetic constitution and the nature of its ability to cross between different species of hosts and to change its level of severity. One can never predict what would be the extent of the severity of a spread of an infection. So I think the organization did the right thing, which is first to announce that there is a spread of infection from one country to several countries, to raise the level of awareness, and to spread the story all over the world. And just contrast that with our previous experiences with emerging infectious diseases, when some countries, we don't need to go there, but some countries basically didn't report what was going on for 6 or 8 months.
Are you referring to the 2003 SARS pandemic?
Absolutely. So consequently, I think the prudent thing was to announce and to start the preparedness to be able to face it. Now, luckily, this is not a very serious spread of infection, not very serious toll on human health today. But again, nobody can predict what will come next season.
Yeah, typically what I've read is that usually there are different waves of a virus attack. What we're having now is the first wave, which is typically relatively mild. But then in, say, later on, a few months later, in 6 months' time, as we approach fall and winter, that we could have a second wave. And the second wave is much more severe. Is that true?
That is exactly what happened in 1917 and 1918. So, I mean, the similarity here is with something we know historically happened. In 1917, there was an increase in the mortality and the spread of flu, but it was not detected because it was not very obvious. And then that same virus came back in 1918 and caused the humongous global mortality that happened in 1918, 1919. So that's just one more feature whereby we cannot trust the influenza virus. We just have to be ready for it.
I see. So you're saying that the second wave of attack could be in part due to the fact that the virus would have mutated,
would have acquired exactly some level of pathogenicity to humans that is higher than what started with.
So how are we in terms of preparedness for that possible second wave?
At this point, we have at least 3 ways of dealing with a pandemic of influenza. So the first is to stockpile the medications, the antivirals that can work against this specific infection. And there are stockpiles in this country, there are stockpiles in most countries, and the World Health Organization has a stockpile which is available to help the developing part of the world in case of a spread of the pandemic.
Yeah, but how large is that stockpile? Is it enough in a really serious, severe outbreak?
No. It is modest.
So what do we do then?
Increase the productivity of these two drugs, and stockpile more of them.
Okay, so are governments doing that?
They are trying now.
They are trying now.
Yeah.
Okay, but we're racing against time, so to speak.
Absolutely.
Yeah. Okay, so what are the other two?
So the other two is, the second is to prepare a vaccine. And the unfortunate situation with influenza vaccines and the current technology that we have does not allow us to make a vaccine very quickly. So a new virus comes, like this H1N1. You have a phase of approximately 6 to 8 weeks to prepare what is known as the seed stock, which is a quantity of the virus that is absolutely characterized that you can give to the producers of the vaccine to start the production cycle. The unfortunate thing is that production cycle necessitates making the vaccine in eggs. And that, by definition, takes another 4 to 6 months.
You mean an egg takes 4 to 6?
No, it's the growing of the virus inside the egg and to get enough of it.
I see.
So, in effect, the technology that we're using today has some limitations. And I'm happy to say that there are now very clear-cut pressure and attempts to come up with new technologies that will allow us to make vaccines against an emerging influenza virus much faster than that. Whether it will be helpful in this case of this current threat or not, I can't tell at this point. But at least there are some attempts to use science and technology that will allow you to make much quicker a new vaccine.
I see. I see. Yeah, tell us a little bit about vaccine and vaccine development. How are they discovered? How are they invented? Is it pure chance, like throwing a dart, or is it, it takes concerted efforts and a lot of money?
Well, it's probably both. Probably both. So most of the vaccines that we have today, that we use in our practice of medicine, are made of the whole organism. The whole organism. So the whole measles virus, the whole influenza virus. And all what we did is to attenuate the organism, to make it less pathogenic, or to kill it. And then exposing individuals to these attenuated, weakened viruses or weakened bacteria or the killed viruses basically primes our immune response. So on secondary exposure to the same pathogen, we are protected. So this is basically the technology that was discovered by Jenner's and his predecessors almost 200 years ago.
I see. How much or how many of the terrible diseases we have are amenable to intervention by vaccines?
Today, we have approximately 30 infectious diseases that are covered by vaccines, out of hundreds.
I see. I see. So yeah, people very often ask, why don't we have a vaccine for HIV, AIDS, malaria, tuberculosis?
Absolutely. Very relevant question.
Yeah.
And the answer is, when we do not have enough scientific knowledge of what are the most susceptible components of that virus, HIV, or that bacterium, TB, or that parasite, malaria, to mount an immune response to protect us. So it is basically the shortage in our scientific understanding of the basic biology of these organisms. After all these years of intensive research, we are just scratching the surface of that understanding. Consequently, our attempts of the last, for HIV, for example, the attempts for the past 27 years have not resulted in any possible successful vaccine.
Well, so is how much does not, perhaps not having had sufficient money for research and development have to do with this? Because those things are subject to sort of political factors. Depending on what government you happen to be in, that they may fund more or less scientific research.
I mean, you will have to divide those three infections particularly, because there has been a lot of investment on HIV vaccine, both from the governments, particularly the government of the United States, governments in Europe, the pharmaceutical industry, and philanthropy. All three did invest very heavily for the discovery of an HIV vaccine.
Have we made good progress?
No, because the barrier is our scientific capabilities and our ability to dissect the basic, detailed biology of the virus. And this is still a mystery for us. Now, contrast that, or just look at the opposite image, the effort on malaria vaccines and TB. Obviously, the investment is not adequate. So unless there would be more funds spent on a TB basic biology, malaria basic biology, to discover what really will determine the components that we can use for vaccination, the effort is going to be a struggle, and would become, maybe one day we'll discover a vaccine, but we'll come out of serendipity, and that is dangerous.
I'd like to ask you a couple more follow-up questions on the scientific aspect, science aspect of viruses and infection. The swine flu, is this something that happened in pigs first, and then the virus went to humans, and took humans as its new host. So in other words, I'm talking about animal-to-human transmission versus human-to-human like the common cold
Sure.
or tuberculosis.
Yes. Well, I mean, historically and scientifically, 60 to 70% of emerging infectious diseases in our world come from jumping from animals to humans. So historically, most of these new infections, emerging infections that we all witnessed, whether it is SARS, whether it is HIV, whether it is West Nile fever, whether it is this influenza, all of these organisms, or most of them, were animal organisms that jumped species from animals to humans.
Are we seeing an accelerating trend in animal to human infections?
I think we are.
Why is that?
For multiple reasons. One reason is we now deal with animals and we live closer to animals a lot more than we did in the past.
We did?
We do.
We do?
We do. So, for example, all the effort to get into the forest, use some of the forest animals in countries in sub-Saharan Africa, or the
You mean for food, for its
food,
fur?
for fur, for domestication, for whatever purpose. I mean, we are interacting with animals a lot more.
I see.
And I mean, there is no question that HIV jumped from chimpanzee to humans. And the interaction between humans and chimpanzee has been increasing over the last 30, 40, 50 years. So that's just one example. As you recall, we think that SARS came from jumping from animals to humans in some parts of China.
Is it the civet cat?
Well, it may be, or even some other animals that infected the civet cat, and then it came to us.
I see. Now, at what point does a virus decide to go from an animal to human? Under what circumstances?
Under circumstances that will favor the transmission.
Which are?
Which are, I mean, for example, close contact with the animal population. Okay. For example, the natural, I mean, if we go back to the influenza virus is basically an endemic virus in aquatic birds. And as aquatic birds get in contact with domestic birds, and then domestic birds get in contact with domestic animals, it's a cycle that leads to the transmission. I mean, and the most dangerous is when it gets transmitted from any of the above species to humans, and then acquires the ability to be transmitted from human to human. That's where we'll really get into very, very difficult situation facing these infections.
Now, what are some of the major infectious diseases in the world today?
Well, I mean, the bulk, the burden of illness from infectious diseases in the world can be calculated by the mortality data, for example. In spite of the fact that mortality data is not robust to express the real burden of disease, but it's an indication. 25% of the total global mortality is because of infectious disease today.
And that's roughly how many
So
millions?
That's roughly
of
15 millions out of the 57 millions that die every year. 15 or 16 out of the 30-something, 40 millions that die every year.
I see. And which are the biggest contributors?
The biggest contributors without the diagnosis will be diarrheal disease and pneumonias in children.
Oh, diarrheal.
Diarrheal disease and pneumonias in children. Between the two of them, they are responsible for approximately 5 million infant and children deaths globally. Then you have the three big ones, the malaria, TB, and HIV. And again, between the three of them, there is another 4 to 5 million deaths yearly, everywhere. And then you had few of the others on top.
Is there a concentration in poorer developing countries from death from infectious diseases?
Definitely. Particularly.
Well, what % of the death from infectious diseases actually occur in developing countries?
So 80% of child and infant mortality from infectious diseases occur in the developing world. That's just one figure which really smacks right in front of our eyes. Okay.
Yeah, later on, I think we're going to talk about, just what is being done or what are being done to manage this situation. But first, I think I'd like to ask you about globalization, or the impact of globalization in the transmission of infectious diseases. As I mentioned earlier, that infectious diseases knows and respects no national boundaries.
Absolutely.
And everybody's traveling so much these days.
Absolutely. And I think infectious diseases and their spread is the most obvious expression of the phenomenon of globalization, because they, as you said, they respect no borders, they respect no continents. Yeah. And here is the H1 influenza, H1N1, started in Mexico, probably, and spread to 30 countries in every continent in the world. HIV started probably in Central Africa, or some parts of Central Africa, and spread to every corner of the world. SARS started in some parts of Southeast China and spread to Toronto, spread to Vietnam, spread to Hong Kong. I mean...
Okay, so sure. While there's nothing we can do about the spread of infectious diseases, that there are ways to respond to that threat. Yeah. So I guess, in developed countries like the United States, we're in a much better position to deal with infectious diseases. Yes or no?
Hopefully.
Okay.
We are.
Explain.
We are. Okay. I mean, one of the difficulties relate to today that the spread of infectious disease, as you said, May, is a global phenomenon.
Yes.
And when a new syndrome happens that our healthcare professionals are not acquainted with, okay, it can present in our country, and it will take some time to detect. So in some ways, the first step, whether it is in this country or anywhere else in the world, the first step is detection. And detection will mean raising the kind of capabilities that the healthcare professions understand and appreciate, that not everything you're going to see is what you studied in medical school. There is going to be few new things.
So you're saying that we're not there yet?
We're not there yet. We're not there yet globally.
Okay.
Yeah.
Okay. But are we better off than the poorer countries?
Absolutely. I mean, what happened recently is the World Health Organization, with the agreement of all the countries of the world, developed this new regulations called the International Health Regulations, which were approved in 2005 and were brought into effect in 2007. And what that regulations dictate is any country has to develop the capability of detection and reporting to the WHO what they see new. Now, you and I will absolutely agree that the ability of most of the developing world today to detect is modest. Okay, so that's something that has to be taken into consideration. But the fact that the organization and every country agreed that you can report what's going on in another country if you feel that this is a new syndrome coming up, gives the international community a little bit of better control on detection.
Okay.
Now, the next step is response. And
talk about that. Talk about response as challenges for poorer countries, response to infectious diseases. So there's detection, problem of detection, reporting, and then there's also access to needed drugs and vaccines.
And that's the challenge. As we were talking about the stockpile of the antivirals against flu.
Yeah.
And if I tell you that the stockpile at the WHO is 50 million doses, your response was, and what would that do in the case of a pandemic? You're absolutely right. Now, does the World Health Organization, have the funds to stockpile higher amounts of these antivirals? Probably the answer is no, because its funding is modest.
Well, you can look at it this way. Why do these things have to cost as much as they do? The high cost of drugs and vaccines is very often cited as the biggest handicap.
That is an absolute problem. That is an absolute problem. And again, the global community and the producers, the manufacturers, have to face this issue by multiplicity. I'm not saying to a private company that is making a drug, go and make it for free. I'm not saying that.
No, that's not fair to the company.
Absolutely. But what I'm saying is there has to be a system, whether it is differential pricing, whether it is by donation, whether it is by buffering from multinationals and bilateral agreement, whether global philanthropy will get into. I mean, there has to be a system to buffer the cost of these containment efforts to the developing world, because they can't afford it.
Right. You're absolutely right. Now, you mentioned differential pricing. Talk about that. Is that you sell the same drugs to different countries depending on the ability of the country to pay?
That is exactly the definition of differential pricing.
How common is that right now?
It is in practice, but it is not to my full expectations. And then there are two problems with differential pricing. One of them is the political process in this country. So in our country here, when you tell the Congress that drug A is being sold for $1 in this country and will be sold for 10 cents in a developing country, there is anger.
Yes, people will say, why can't we get it for 10 cents?
Exactly. And if we get it for 10 cents, then the producer is going to go out of business.
And they won't make it.
They won't make it.
Yeah.
Absolutely. You're absolutely right. So consequently, we as a country, I mean, our political process has to appreciate that differential pricing is the contribution of the United States to the overall well-being of the world. And it is not at anybody's expense. It is providing the necessary treatments at the level of what these people can afford to pay. And if they can't afford to pay the higher prices, then there is no point in saying, how can they take care of their illnesses? Those illnesses are going to foster and spread and come to our shores. So our investment in what happens overseas is equal to should be equal to our interest in what goes on in our own country. And HIV didn't start in this country. We spend billions of dollars today to take care of that infection in our own country. This infection happened over there, and if we were cognizant of it 40, 50 years ago, we probably could have been much more diligent in responding. That's just one very simple example.
Okay, so see, I like to just sort of mention, as an aside, an experience I had in China last year. I visited some government officials there and was told that they would like to have the human papilloma virus vaccine for their at-risk population, but prices are too high, they cannot afford it. So then, listening to you, are you saying that it's possible that China could get a discount on the price of the HPV vaccine for cervical cancer?
Oh, China has to get a discount. I mean, if the producers of the HPV vaccine are interested in seeing that the impact of that vaccine, and remember, we're talking about a vaccine against cervical cancer. 85% of the cases of cervical cancer in this world occur in the developing world. 85%. So every year there is approximately 500,000 new diagnoses of cervical cancer in young women in this world. half of them die. Half of them die every year. So if we are serious about reducing the burden of illness, all of us have to get together to see that that vaccine will be provided in an affordable price to the people who need it most. And I'm not saying again that the burden has to fall on the producers alone. It has to be the producers, the high-income countries, global philanthropy.
Which you mean aid, foreign aid.
Foreign aid, and so on. The totality of this effort has to be a global effort. And if that happens, we'll get the vaccine.
Yeah, because humanitarian considerations aside, there is the question that we're all in this together indeed.
Absolutely.
Because of the nature of these diseases.
Exactly.
Infectious diseases means that, you and I can get it.
Absolutely.
Yeah.
Absolutely.
Yeah. Tell me about, one also hears very often about compulsory licensing. What is that? And does that help with the situation, help developing countries gain access to drugs they need?
Well, I mean, the compulsory licensing is a phrase that has come to our discussion out of the Doha and the WTO agreement. And the idea is, if a country faces a public health emergency, it can enforce compulsory license on a patented drug so as it can be produced locally to satisfy the needs of their own people. So that's the theory. Now, it might be a reasonable theory until you start examining. Let's just say that country X, which is a poor, underdeveloped country that is just making it, has an emergency, and it will apply compulsory licenses. Most of these countries do not have the ability to manufacture these compounds at their countries. So in theory, it's an interesting concept. In practice, it might not be really that viable. And I would.
But there are companies in India, in Brazil, that make vaccines and drugs.
Yeah, but compulsory licensing does not allow you to make it in one country and import it to another.
I see.
So compulsory license will apply to your own country. If you need it for a medical emergency, you go and make it. So that is why that system isn't really as robust as it was originally conceived. Now, there are two countries that practiced it under certain circumstances, Brazil and Thailand, as they were introducing the first generation antiretrovirals. And they used
HIV/AIDS.
For HIV. So, and they used the threat of compulsory license and the negotiation with the drug companies, and in the final analysis, they managed to get the prices to where they can afford it.
Yeah. So I wish we, unfortunately, we don't have time enough to really go into this, but just from the way you talk, I think that we seem to be a long, long way away from having, from solving the problem of affordable access to needed drugs and vaccines for poorer countries.
No, we're not.
We're not?
We're not.
Huh?
We're not. Because it will take 3 or 4 things. One is global leadership, what I call global activism. I mean, it is not enough just to say this is something that is important. People ought to use it if they can afford it. That's not good enough.
No.
Okay. We need global activism. We need also political will in these countries, in the developing countries, because they are still very divided between their security concerns, their priority concerns, their whatever. So these countries don't come up with very clear cut message about what is needed.
Public health often is not the top priority.
Absolutely. Third, the manufacturers in the developed world have to start playing a much more visible role, whether it is through differential pricing, whether it is through sub-licensing to manufacturers in less costly countries like India or China or Korea and so on. And the global aid, the global aid effort from the developed world has to start shaping up into some system of prioritization, not fractionation, not what is new today. It has to be, I mean, development is going to take us, I mean, to catch up. The developing world, to catch up with us, will need between 50 and 100 years. And it's not going to happen because of tomorrow. It will happen on a protracted basis, and it needs a plan that will last that long.
I'm afraid we have to go, but just very quickly, in terms of a grade for this global coordinated effort, what kind of grade would you give it?
For the influenza? Or
No,
for the totality?
Totality.
5 out of 10?
Halfway there.
Halfway.
So the glass is half empty and half full. I'm afraid we have to go. Thank you very much, Dr. Adil Mahmoud, for being our special guest today. And thank you for watching. I'm Mei Chang for International Forum. See you next time.